Modern supply networks are massive, decentralized ecosystems. Managing them requires tracking thousands of moving parts across continents. That is the domain of supply chain visibility. In this breakdown, we will deconstruct the architecture of supply chain visibility. We will look at the specific structures that make it work, the operating principles behind it, and how it is systematically applied across global networks. The primary goal of any visibility initiative is to break organizations out of fragmented, reactive data silos. Without a unified view, departments and partners operate on outdated or incomplete information, forcing them to respond to disruptions long after they occur. The first major advantage outlined in the literature is an improvement in decision quality. When planners can see the actual status of materials in real time, they can make faster, highly accurate adjustments to their schedules instead of relying on forecasts. This operational clarity translates directly to the balance sheet. By knowing exactly what inventory is available and where it is located, companies optimize their working capital. They carry less excess safety stock while simultaneously preventing costly stockouts. The ultimate objective is to establish a single version of the truth. When sales, operations, procurement, and logistics all operate from the exact same real-time data, the entire network can move in unison. We define supply chain visibility academically as the ability to access, monitor, and share accurate, timely information. Crucially, this is not an internal metric. An organization cannot claim to have true supply chain visibility if it only tracks goods within its own four walls. The operational boundary of visibility spans the entire end-to-end network, reaching upstream to a supplier's suppliers and downstream to the customer's customers. Across this span, organizations track three primary flows: physical inventory movement, real-time order status, and available production capacity. The value of this data is strictly tied to its latency. To be effective, this information must reflect the network status in real time or near real time. Yesterday's data cannot solve today's bottleneck. True visibility is the comprehensive, continuous illumination of the entire value chain, replacing operational blind spots with shared intelligence. Let's anchor that academic definition by looking at how visibility functions at specific points in the network. Basic logistics tracks containers via GPS to ports, but deep operational tracking goes further. Retailers see stock across all regional centers, and manufacturers actively monitor a supplier's capacity. Downstream, it means tracing a customer purchase from order confirmation to final delivery. To determine if a network actually possesses this capability, we use specific benchmark criteria. Not all data collection qualifies as visibility. A common trap in logistics is confusing visibility with data overload. Generating thousands of passive location pings is useless unless that information can trigger an operational response. According to the structural guidelines, a robust system must exhibit 5 key traits. It must be real-time, highly accurate, span end-to-end without siloing, be shared across partners, and most importantly, it must be actionable. A fully mature visibility architecture physically transforms isolated data points into shared intelligence that drives immediate, informed decision-making. Achieving this level of coordination requires a specific technological architecture. Visibility is built on an integrated, multi-layered technology stack. The foundation starts with raw data from ERP, warehouse systems, and IoT devices. This feeds upward into the second layer, translating raw inputs into specific information types, like inventory levels and lead times. To make sense of information flowing from disparate sources, the system requires an integration layer. Cloud platforms, APIs, and EDI protocols aggregate this data, feeding it into centralized control towers. Finally, we cap the entire system with governance and process. Without strict cross-party data sharing agreements and rigorous protocols, the lower technological layers will simply distribute flawed information at a faster rate. Realizing this level of visibility involves managing a complex ecosystem that relies as much on inter-organizational governance as it does on the technical stack. When this technological stack is successfully implemented, it changes the physical mechanics of the supply chain through a specific operational theorem. The causal mechanism is straightforward. Sharing high-quality information directly reduces physical uncertainty in the network. The mathematical consequence is a direct reduction in protective safety stock buffers. Companies no longer stockpile excess materials to guard against the unknown. There is also a secondary principle at play. Shared data enables collaborative planning across different organizations, which creates better synchronization. By synchronizing operations, the network mitigates upstream demand signal distortion. This dramatically reduces the systemic variability known as the bullwhip effect. SCV acts as a structural theorem. By replacing physical uncertainty with shared data, supply networks inherently optimize their inventory and reduce systemic variability. These theoretical principles of uncertainty reduction form the basis for advanced strategic management in active supply networks. Managers use this continuous data flow for complex applications, like multi-echelon inventory optimization, determining exactly how much stock to hold at various tiers, and to drive highly accurate sales and operations planning processes. It also serves as a critical risk monitoring tool, allowing organizations to detect port congestion or early warning signs of supplier disruptions before they impact production lines. However, several real-world friction points complicate end-to-end integration. While mapping data formats between disparate systems is a significant technical hurdle, the most substantial barrier is cultural, a fundamental lack of trust between corporate partners. Organizations struggle with persistent internal data silos across their own functions, as well as the severe cybersecurity risks involved in exposing operational data to external third parties. The true barrier to implementation is rarely a lack of software capabilities. The delay comes from the structural and cultural friction of convincing independent companies to share sensitive data. To bypass these friction points, the industry is turning to a new technological frontier. We are observing a major operational shift away from merely descriptive visibility, reporting what just happened, toward AI-powered predictive visibility that anticipates bottlenecks before they form. This includes the rising implementation of digital twin supply chains. These digital replicas allow managers to run advanced scenario models and disruption simulations against live network data. Simultaneously, there is a strict, increasing mandate for ESG transparency tracking to ensure environmental and ethical compliance across every tier of the supply base. Ultimately, supply chain visibility is an actionable data architecture that transforms physical logistics into shared network intelligence. By establishing a single version of the truth, it structurally reduces operational uncertainty, which directly minimizes the destructive impact of the bullwhip effect. Today, massive global supply networks depend on visibility as the foundational architecture for maintaining operational coordination and resilience.